Hello students, today we're going to be learning about the tangent ratio. Let's go ahead and begin with a warm-up. Pause your screen and complete this. Okay, looking at problem 1, we notice that this is a 45, 45, 90 triangle. So as always, our first step would be to draw the mini triangle right next to it, facing the exact same direction. So from the mini triangle, we remember that the legs are the same because it's an isosceles triangle. And the hypotenuse is square root 2. Now, since we have two similar triangles, a small one or a mini one and a big one, we can set up our proportion. So let's go ahead and do this. We have 5 over the square root of 2, so looking at this hypotenuse and this hypotenuse, that equals x over 1. And again, that's this leg and this leg here. So we can cross multiply. We get x times square root 2 equals 5 times 1, which is 5. So you can see how we cross multiplied here. And to get x by itself, we need to divide by square root 2 on both sides. So we get x equals 5 divided by square root of 2. We know from a long time ago that it's not okay to leave a square root or a radical on the denominator of a fraction. So to get rid of that, we multiply by square root 2 over square root 2, and we can multiply straight across. So that would be 5 square root 2 over 2. And this would be our final answer for x here. Looking at number 2, we have a 30, 60, 90 triangle. So we're going to start by just drawing the mini triangle right next to it. Make sure that you're putting the 30 and the 60 in the same exact spots as the original. So remembering back to Francis Purple, we know that the short leg is opposite 30, so this is 1, and the hypotenuse is double, so I put a 2 there. And the long leg is square root 3. So noticing this, I can see that they gave me the short leg of 5 because it's opposite the 30. That means the hypotenuse is double, so I can just write 10 here. 5 times 2 is 10. And I can see that the long leg is square root 3 times the short leg, so this would be 5 square root 3. So we have x equals 10 and y equals 5 square root 3. Okay, let's go ahead and move on and learn a little bit about some trigonometry. So at the end of this lesson, you should be able to solve problems involving SOHCAHTOA. This is an acronym that you'll hear many teachers say just to remember the different trig functions. So there's sine, cosine, and tangent. Our focus for today is the TOA, the tangent part. So the T stands for tangent, O stands for opposite, and A stands for adjacent. So we write that this way when we actually solve problems. The tangent of x, this is an angle measurement, so it could be, for example, like the tangent of 30 degrees, equals the side opposite to it divided by the side adjacent to that angle. You'll see as we do a few examples how this is applied. Okay, let's look at example 1. So it says, write the tangent ratios for angles A and B. So we're focusing on the TOA part. That tangent is opposite over adjacent. So for example 1, we're going to write the tangent of A equals, so looking at A, I'm thinking, what is opposite to angle A? So directly opposite is y. So you can see how it's opposite. So I put y on top over, and the A stands for adjacent. So adjacent to A is this x. So we're doing opposite over adjacent. And now we can do for B. So let me clear this writing here. So let's do the same thing. So for the tangent of angle B, so now our eyes are looking right here at B. So we want to do opposite over adjacent. So opposite of B is x, adjacent to B is y. so we can leave it like that. Let's move on to example 2. We're going to do the same thing, just writing ratios. We're not solving anything yet. Let me move this over just a little bit. Okay, so the tangent of angle A. So we're focusing on A right here. So we can write that it equals opposite over adjacent. So opposite A would be 5. And adjacent to A, right next to A, is 2. And I can leave it like that. Tangent of B. So now I'm looking just at angle B. If it helps to circle it on your paper, you can do that also. Looking at B, opposite B is 2, so I put that on top. Adjacent is 5. And we can leave it just like that since it just asked us to write the ratios. Now let's go ahead and find the length of the indicated side. So in this case, we're given 42 degrees, and we're also given that it's a right triangle. We need to solve for x. So we're going to write this down as tangent of 42 degrees. We always write the angle measurement right here, equals, we need to put opposite over adjacent. So looking at the 42, opposite is x, so I put that on top, adjacent is 4. Okay, so it's written like this. To solve this, I always put a 1 on the bottom so that I have 2 fractions here, and you can just cross multiply. So we have x times 1, this part right here is x, and tan 42 times 4, so I'll write that as 4 times the tangent of 42. And this we're going to need our calculator for. So taking your calculator, be very careful how you enter it in. So I'm typing in 4 times the tangent of 42. And I'm making sure that 42 is in parentheses. And you end up getting 3.6. I'll round it to the nearest tenth there. So this is the side length, that x is 3.6. Let's look at example 4. So same thing, we're going to use tangent. So tangent of 27 degrees equals, so opposite is 12, adjacent is x. Just like before, so I need to put a 1 on the bottom to create fractions here. And now let's cross multiply. So on one side we have x times the tangent of 27 equals 12 times 1 is 12. So we want the x to be by itself here, so I need to get rid of tan 27. So that means I'm going to divide by tan 27 on both sides. So this part goes away. I'm left with x equals this part. So again, take out your calculator. You're going to type in 12 divided by tan 27. And you should get 23.55, so I'll round that to 23.6. So that means x, the side length, is 23.6. Alright, let's move on and do one more example. So now looking at example 5, this asks to find the measure of the indicated angle. So notice what's different about this problem here. They give us these side lengths. This time we actually need to find how many degrees is angle A. So we'll write it out as we did before. So tangent of A, which we don't know what it is yet, equals, so looking at A, we have opposite is 3 and adjacent is 4. So now we need to use a little trick with our calculator. So what I need you guys to do, what we need is to type in the inverse. So tan inverse of angle A. So usually at this point, if we wanted to get A by itself, we would divide by the tangent on both sides. To do that in our calculator, we need to use a function called the tan inverse. So if you look on your calculator, you need to push second, so it should be in the top left corner, and then tan. And you should see it pop up just like this, tan inverse. We don't say tan -1, it's just called tan inverse. And then we type in 3 over 4, so 3 divided by 4. And you should end up getting 36.86, so we'll round up to 36.9 degrees. So again, look at the note down here and make sure you're writing this down. If you are solving for an angle measure, like in this case we are here, be sure to use the inverse function on the calculator. Okay, try these problems and I'll see you in class tomorrow.